Morning, good afternoon, very good evening. My name is Satyam and I'm visiting scholar from Blue Marble Space Institute of Science. And I would like to thanks to the Relca community for providing me this wonderful opportunity. So today I'm going to talk about what are the factors which could influence the future Martian population. So just to get started, I would like to give you a brief about how Mars is. So Mars has some common properties similar to that of Earth. And what are those properties? It has atmosphere, it has axis tilt, it has seasons, it has gravity, though less, but yes, it is somehow similar to the Earth. Talking about the atmosphere, it has 95.9% of CO2 with traces of oxygen, carbon monoxide, and water in its atmosphere. While talking about the seasons, Mars have seasons at its pole. As you can see at the right side of this figure, you can see the expansion and the contraction of the polar ice cap running along with the season. So let us just assume that human is somehow able to build a spaceship and a hypothetical spaceship which could transport human to Mars into just one day. So what would be the factor which would influence the future Martian population? Here I have created a hierarchical overview of overview of those preliminary factors which would affect the future Martian population. As you can see, the ISRU advancement would be the utmost factor to affect the future Martian population among these four, while engineering structure or living quarters would have the least effect on the Martian population. So let's jump into these factors one by one to give an overview or to give an idea about how these factors are going to place an upper limit into future Martian population. All right, ISRU. So just to brief, like what exactly is ISRU? So ISRU is translating one kind of the resource into the another. As you can see in the bottom left, we with some chemical reaction, we can convert CO2 into the oxygen, right? And one of the instrument which is performing this science is MOXIE, right? So what else can ISRU perform? So, well, ISRU can help us to produce nitrogen, which can act as a buffer. ISRU can also help us in producing the food facilities from all the elements which has already been present in the Martian regolith. So more the resources we can produce through the ISRU, the more the people we can sustain on the Mars. So this is the one aspect, which is technological aspect of how ISRU is going to affect the future Martian population, right? The next factor within the ISRU will be its implication, that how ISRU is going to get implemented on Mars. In 2015 and 2017, US and Luxembourg has passed their own laws stating that USA and the ESA states have the right to take out the resources from the asteroid. If I talk about, so those objects were near Earth objects. So based on such practices, based on the kind of laws which has already been passed and which will be passed before the first human can step on Mars, we can just be skeptical of how Martian legislation would be. Would it be much more conservative type, or would it be something more belonging to practicing the ISRU at the global level on the Mars, so as to harness more and more resources? So this is how ISRU is going to basically affect the Martian population along with its implication. The next factor is energy requirements. Just like on Earth, energy is the crucial element for a living being. So Mars is going to be much more industrial as compared to that of Earth. Now, why I'm saying this is basically because Mars, nothing is available on the Mars. We need oxygen, we need support, we need life support habitats, we would be needing agricultural needs. And for those needs, we have to have some kind of the energy which could fulfill our needs, right? So it is based on this, it has been estimated that an individual on the Mars is going to need somewhere around 2 to 5 times more than that of an individual which is residing on Earth, right? So obviously solar energy is not going to be the best option to adopt. Well, nuclear power. Well, what option we have? Any alternative? Well, yes, we have nuclear power. Why? It is reliable. It has a high energy density. It is passive heat. It provides a passive heat for the habitats. But who's going to determine how many nuclear reactors are going to build upon the Mars? Well, it is going to totally depend upon the geopolitical factor that the Martian government will enact on the Mars. The more the energy supply we would have on the Mars, the more resources we can create. The more resources we can create, the more number of the people or the population we can sustain on the Mars. So this is how energy is going to affect the future Martian population. So number 3 is the space and the Martian area. For those of you who think that Mars is not large enough, or let's say Mars doesn't have that much greater area to fit every human population onto it. So let me just give you an overview. So Mars has an area of around 144.8 trillion meters square. Now, if you fit every single human on the Mars, it would turn out that you can actually fit 1.5 quadrillion people on the Mars. Well, that's a huge number, but this number is not indicating a sustaining one. So we are just throwing those people out onto the Mars to die there. So after the first level of the settlement, it is predicted that much of the area on the Mars is going to get covered up by the ISR equipment, or let's say agricultural land, or any other technological equipments. After predicting all these things and after calculating all these things, there's a number which is that each settlers would require around 200 meters square of Martian area to sustain. Now, it might also be possible that the future colonies, the Martian colonies, would adopt some clever move, which is to adopt the number of the most sustaining data which the Earth previously has. For example, as you can see here, the example of the Norway, which as of 2020 was the most sustaining country on the Earth, and it sustained around 15 people per kilometer square, followed by the Sweden. So it might be possible that these Martian colonies might adopt such data. And if we extrapolate these numbers on the global level, what we would find is that Norwegian model would hit 2.1 million data, while USA model, if colonies go for a USA model, which is the average, then it would have around 4.9 billion people living on the Mars. Believe me or not, this is the one of the most important factor, which is the governance structure to affect the future Martian population. Now, why I'm saying this is basically there are going to be a policy on Mars. A governance structure would place an upper limit on the Martian population. There could be the policies which would restrict the only number of people living on the Mars. There could be the policies which would restrict the immigration rate from the Earth, or let's say the fertility rate. There could be the policies or the propagandas which would limit or secure the gender ratio, or the policies which would prevent the outpacing of one kind of the age group over the another. So these are the some policies which a Martian government might take to prevent any unsustainability on Mars. And so so as you can see, any other thing which might happen on the Mars other than policies under the governance structure is basically some uncertain actions of public, which would basically force government to change their laws and the policies, and that would directly affect the population on living on the Mars. Okay, so we are now at the at our final factor, which is how engineering structure is going to affect the Martian population. We just discussed that the Mars, we could take and harness the elements from the Martian regolith using ISRU. So Mars has aluminum, titanium, nickel, silicon dioxide when it's regolith. So if we can harness these elements, so we can use the dome-shaped structure and icosahedron-shaped structure to fit human population onto the Mars, because these geometrical shape basically offer lower area to volume ratio. But even though if we acquire such technology which could construct these habitats on the Mars, the enacted political element might or may hinder the construction of quarters on the Mars. So what kind of the political elements could those be? So this could be if a Martian government is facing a prolonged economic recession, it would basically limit or restrict the habitats construction further on the global level. Or if a Martian government is much more conservative type, it would also going to affect the habitats or the quarters which are going to get established on Mars. And as you can see on the left is just a demographic, it's just an illustration of how SpaceX is going, how SpaceX is planning to construct the habitats on the Mars itself. Just to conclude with all the points that we have discussed, so we can say that if we continue to progress with our with our current technological development, so yes, our human settlement on Mars is inevitable. But the thing which is going to decide the human population on Mars is will be the not only the governance structure, but also be the ISR, but also would be the ISRU structure and how many reactors are going to get set up on the Mars. With that, I would like to thank you very much for having me, and thanks for bearing me. If you have any question, feel free to hit me at my email ID. Thank you very much.